Hello everyone, today we're going to be looking at inclined planes. So the inclined plane is one of the most tested force scenarios in physics. Here's exactly what you need to know. So when an object sits on a slope at an angle theta, so this angle here is theta, weight acts vertically downward with magnitude. So if we were to draw the weight vector, it would act down this way. So that is Fw. But because it does not align with the slope, it has to be resolved into two components. So it has to be resolved into the vertical component and the horizontal component. So if we look at the horizontal or the parallel force, so the force acting parallel to the inclined plane, the formula is mg sine theta, and that will tell us the force parallel to the slope, so the force down the slope. Okay, now normal force is the force that acts perpendicular to the surface. So this is the normal force, and this is F parallel. So the normal force, we have to resolve the weight component into its vertical component. So that is equal to mg cosine theta is equal to the normal force. Okay, now there's also friction. So friction also acts parallel to the slope, and it opposes the motion. So if this mass, or this box, was sliding down the slope due to the parallel force and the weight force, then the friction force would be opposing that motion and acting up the slope. Okay, now there's also can be another force called tension. Now tension is when there is a rope or cable of some sort applied to the box. Then we have the force along that cable or along that rope is called tension. Now there can also be applied forces. So applied forces that act in the direction specified. If it is not parallel to the slope, you have to resolve it into components again. Okay, let's go through an example now. So I want to have a look at this example now. So the question is, there is a 10 kg box that sits stationary on a 30 degrees slope that is held by a rope. So I've drawn that here, and the question asks us to complete a free body diagram with all the forces labelled. So we need to find all the forces here. We need to find the tension force. We need to find the parallel, vertical, and the weight force. So let's do that. Our normal force, so this force here, like what we said before, is equal to is equal to mg which is our mass, 10 times, so gravity 9.81 is equal to our Fw force, so we get 98.1 is equal to our weight force. To find the vertical and horizontal components, so the parallel component is equal to, it's going to round this here to 98, 98 sine 30 and that's going to be equal to 49 newtons. So that's going to be this force here. This is going to be our F parallel, and it equals 49 newtons. Now if we look at the normal force now. So our normal force is equal to mg, or 98, cos 30. And that gives us 84.9 newtons. So that's going to be our Fn is equal to 84.9 newtons. Okay, so friction and tension are both acting up the slope to keep this box stationary. So we'll have F, friction, and also tension here as well. We have established that for this box to remain stationary, there has to be a horizontal force of 49 newtons pulling the box, or keeping the box stationary along that inclined slope. Okay, so to summarize, weight resolves into mg sine theta along the slope and mg cos theta into the surface. The normal force equals mg cos theta. Friction opposes motion parallel to the slope, and always use axes aligned with the slope. Thank you.